we have done this with relative rates of growth or not at all?
Not at all. Remember, relative rates of growth, you must be approaching infinity.
Oh, you're right. Josh, she's right.
She's always
Okay.
right.
Any questions so far? Okay, so now we look at the numerator and we can simplify it. We have x minus x, so those cancel. And now I'm just going to distribute the negative sign to the rest of the term. So I have positive x to the third over 3, minus x to the fifth over 5, plus x to the seventh over 7, minus, and so on. And then I'm going to just put over the ditto sign, meaning the same denominator as before. I didn't change anything. Okay, so now I want to try to cancel some stuff out. Here, I notice that the lowest degree is 3 in the numerator, right? It starts with x to the third and then just gets higher after that. And here I have an x to the 3. So what if I pull out an x to the third in the numerator? That can cancel out with the x to the third in the denominator. So I'm going to distribute out an x to the third in the numerator. So x to the third times 1/3 minus x squared over 5 plus x to the fourth over 7 minus dot dot dot. And then over just the same denominator as before, x to the third times 1 minus x squared over 2 factorial minus x to the fourth over 4 factorial minus x to the sixth over 6 factorial, and so on. Questions? So now my x to the thirds cancel out, right? So that now just becomes without them. So I have 1/3 minus x squared over 5 plus x to the fourth over 7, and so on, divided by 1 minus x squared over 2 factorial minus x to the fourth over 4 factorial minus x to the sixth over 6 factorial, and so on.
30 plus x to the fourth.
Oh, yes, thank you.
This is easier than doing elliptic tab?
Huh?
This is easier than doing elliptic tab?
Oh, yeah, you try it.
That's great.
So now, if we try direct sub, okay, the numerator I get 1/3 minus 0 plus 0. And I know those terms are just going to keep being 0 because the exponent just gets larger and larger. In the denominator, I have 1 minus 0 plus 0, and so on. And again, the exponent just keeps getting larger and larger, so all those terms are just going to go to 0. And now I'm just left with 1/3. Cool, huh?
If you come to my review session, I'll show you to do this with RRG.
Good luck with that.
There's an RRG.
I knew you were in RG. I knew it. I'll be there.
Don't expect you there.
Any questions?
Do you have like appetizers and cokes and
Yeah.
just ask.
Mock final.
Okay. No questions on 11:10? All right, so let me just briefly talk about 11:11.
Make a
I don't
wish.
know if you just want to stop the video because now I'm just going to be talking projected here. So you can just stop it now. I'll get a videotape for the next class. do tomorrow is now due Wednesday. So the one on 11:10, I'm just going to make it due Wednesday in case you want to come to office hours, because we won't finish that material until today's lecture. Okay? But don't start that at the last minute, because I will be giving another exercise tomorrow that will also be due Wednesday. So you're going to have 2 due Wednesday. So just get started on that early, okay? And then if you want, you can come to office hours on Wednesday. Or if you know when you can come tomorrow. Okay? Any questions before I start? Where is everyone? We're missing the most exciting day of the semester.
Why?
Today we do sum of series. It's my favorite part. Oh my god, that's what okay, so we want to find the sum of this series. Okay? So here we have a fraction in the denominator, which means that I want to flip it. So here I have the sum from n equals 0 to infinity of -1 to the n. Okay? This becomes pi over 3 to 2n plus 1 over 2n plus 1 factorial. Okay, and so now let's write out the first few terms of the series. Okay, so when I plug in n equals 0, I get pi over 3. And then I plug in n equals 1, and I get minus pi over 3 to the third over 3 factorial. And then I plug in n equals 2, and I get plus pi over 3 to the fifth over 5 factorial, and so on. Okay, and so I want to find the sum of this series, but since this series goes on forever, it's an infinite sum, it's impossible to keep adding up these terms because we would be doing that forever and we would never get an answer. Okay, so we want to find some other way to find the sum of this series. And so what series does this look like? Sine, right? So here, sum x equals the sum from n equals 0 to infinity of -1 to the n times x to the 2n plus 1 over 2n plus 1 factorial. Okay, so this is in the form of sine x, except here x equals pi over 3. Okay, so we just replace pi over 3 in for x there. Is in the form of sine x, where x equals pi over 3. So if x equals pi over 3, I'm just replacing pi over 3 in for x here. Then I could do the same thing on the left side and replace pi over 3 by x on the left side. So that would be sine of pi over 3. And what is sine of pi over 3? Square root 3 over 2. Oh my god, wasn't that so much fun?
That's the answer.
Yeah! So yeah, isn't that amazing? So we took an infinite series and we didn't have to add it all up. We just know that it equals square root 3 over 2 by the sine Maclaurin series. Pretty mind-blowing, huh?
Like frustrates me.
Why does it frustrate you?
Because like we've been doing this whole time, like no, you can't get an answer.